Now we're going to look at a new kind of section called an offset section, and you can see from looking at this cutting plane line from ASME why it's called offset. And this is a strategy you can use if you have some features that are not sitting in a line, but you really want to make a section through all of them. So here in this part, the drafter wanted to section through this small hole and this boss with a counterbore in it and this slot. And instead of making 3 separate sections, they made one offset section. So the imaginary saw blade that you use to cut through the part actually has steps in it. It's zigzag. And here is the cutting plane line that shows the shape of that zigzag saw blade. Notice how in the section view we do not see any edges from that cutting plane line. You are just showing the material that the saw blade cut through with your hatching, but you are not showing any edges. And the reason for that, you can probably imagine, is that if you were to do it wrong and put edges where the saw blade cut through, your machinist would think, oh, I'm supposed to make a corner there. I wonder what that edge is. But of course there is no corner, there is no edge. This is just you slicing through your part. So no lines, no edges where your cutting plane went through, just plain old hatching. Here's another example. Here you can see this drafter wanted to show through this raised place with a hole. They also wanted to section through this boss with a counterbore. They wanted to show the other raised place, and they wanted to show the radii inside. This is obviously some kind of cast part. We don't know whether this is cast metal, like, cast iron, or whether it's plastic injection molding. It's something like that. We saw in an earlier lecture that ASME has an order of precedence for the line types. Object takes precedence over hidden and so forth. And we also saw that cutting plane line takes precedence over center line. And here's where that becomes relevant. If you have a part with center lines in the part, and you put a cutting plane line over the top of those center lines, what you need to do is go in and delete those center lines. If you don't, you'll have thin stretches of center line showing through the gaps of the cutting plane line, and it will just be incomprehensible. We want only one line here, and if you're using a cutting plane line, that one line is a cutting plane line. So delete the center line. Another thing you need to do when you're doing an offset section is find a way to make those arrowheads. You will recall from a couple of days ago, we looked at the ASME standards for these arrowheads, and we saw that in a cutting plane line, the arrowhead is twice as big as it is in a dimension line. In other words, the arrowheads are 1/4 of an inch long. Well, that means you need a new leader style. So you probably have an existing leader style where your arrowheads are 1/8 of an inch long, and we'll just leave them that way. You can go into leader style and create a new style, and you could call it cutting plane or something like that, and just for that one style, make the arrowheads 1/4 of an inch long. In other words, they're twice as big as a dimension arrow. Here's the assignment we're going to do. I know this thing looks a little baffling. It's a funny shape. there's a bunch of stuff going on. So I have two supports to offer you. One, I have a 3D model of this part. And two, we'll go look at how we might start drawing this in CAD. So just to get oriented, this is at its heart an L shape. Okay, on the shorter leg of the L, we've got a chamfer on one side and some kind of notch on the other side, but it's still the leg of an L. On the longer leg of the L, we've got a rounded off place at the end, and it has a slot inside it. All right. And stuff is happening with that slot, it looks like. Looks like that slot might be sort of a slot-shaped counterbore. And then also in that leg of the L, we have two counterbored holes. And here is the call-out that tells us what size the hole and the holes and the counterbores are. And then he is giving you dimensions to show how thick the legs are and how far to go to the notch, how far to go to the center of the slot and the radii, how far to go to those holes. But whew, that's a lot. So we'll look at this in CAD. Let's go look at that 3D drawing. So here it is in AutoCAD. Now, let me go to Model Space. Here is where I made that part in 3D, so that if you want to, if you find it helpful, you could go over here and get the Orbit command and just move it around and see what shape is this thing anyway. Okay, I'm beginning to get the idea. Then, if you go to Paper Space, the B-size layout, I have made 3 viewports into that Model Space window, and in one of them I actually just showed this part in isometric view. And we'll double click to close that. In the top viewport, I showed it in a top view, and in the bottom viewport, I showed it in a, whatever you want to call that, a front view or a side view. So these really are, let me see, I'll do a 3D orbit here so you can see, oh yeah, that really is, whatever view you call it, an orthographic view anyway, of that 3D part. Right there. When you're looking at this Paper Space, I just want to point out that AutoCAD's 3D software does not have an efficient way of showing hidden lines, and it also has a habit of showing, forget what you call these, I think they're silhouette lines, where an arc is tangent to a straight thing. It actually puts in a little thin line. That is wrong if you are trying to make just an orthographic view. This is AutoCAD showing us a 3D thingy, but in your drawing you would never show those lines where the arc is tangent to the flat thing. All right, in the next video we will look at how would we draw this thing.